We will start on time. It is 11 exactly. So a very good morning to you all. I hope I am audible. Uh, Today, I, Dr. Bhanu Verma, with my colleague, Dr. Lipika Patnaik, are going to take you along with to the next lecture series in the monthly lecture series organized by CSIR IPU. The lecture in this series is by Dr. Kamlesh Prasad, who's a senior principal scientist at CSMCRI Bhavnagar. Before we start, I'd like to give a very brief intro on Dr. Kamlesh Prasad. Dr. Prasad has been a scientist, senior principal scientist in CSMCRI. He's heading the division of natural product and green chemistry, and also he's taking care of business development and information management divisions. He's also a professor in Academy of Scientific ACSIR and has been a recipient of many awards. Notable among them are CSIR Young Scientist Award in 2010, CSIR Award for SNT and Rural Development in 2018, in 2013, CSIR CRI Best Technology Award 2018, and many others, which includes national and international award recognitions. He has, to his credit, 130 publications and 22 patents, including international patents also. Today's lecture is on the topic of intellectual property right protection, commercialization, and commercialization aspects of seaweed-based technologies. I will now invite Dr. Kamlesh Prasad to please start his lecture.
Yeah. Thank you, Dr. Verma, for the nice introduction. I hope I am audible to all of you.
So you are audible.
Okay, good. So I'm going to now share my presentation. Hope it is. Can you see this presentation? Hello, can you see this?
No, sir.
I've shared. Is it visible now?
It is visible at our end. At CSIR IPU, we can see it in the presentation mode also. So
Yes, it is visible at CSR MP also.
Okay, good. So should I go ahead?
Please do.
Yeah. So good morning to all of you, and thank you very much to IPU for giving me opportunity to talk in front of my CSR colleagues. This is the first time I'm talking to all of you about intellectual property right protection and commercialization aspect of seaweed-based technologies. Since we are working on seaweeds, so my topic will mostly cover the seaweed research and the commercialization aspects, and I will only cover the technologies which I am involved. So since it is for individual things, so I'm covering only the individual things. So this is our So this is our institute. Just to tell you about the institute, that is 1954. We have been established on April 10th, and also we have a field station at Mandapam. So this is in Tamil Nadu. This is, we call it Marine Algal Research Station. And this Mandapam station, we used to develop cultivation of seaweed technologies. So seaweed cultivation technologies we normally do there. And these technologies were developed, and then the downstream processing and other things that are happening in CSMCR Bhavnagar. So Mandapam also we have a running seawater facility. So you can see here, this is recently developed, and here we can do artificial seedling production for the seaweeds. So this is our mission, that we are working mostly on the salt, water, and marine chemicals. And you can see the seaweed is one of the most important area where CSMCR is working. And we do work on halophytes, we do work on marine biotechnology, we do work on marine microbes, marine bioactives. processing products and food and other things. So mostly our research is run around marine resources, and we try to explore, harness, and transform the marine resources for the good of the people of the country. So that is what we're trying to do in marine marine area. So these are the some of the seaweeds. And just since my topic will mostly cover the work we have done on seaweeds related technologies. So these are the some of the seaweeds you can see here, which are commercially very important. Commercially important because the products derived from these seaweeds are commercially used in various products. So that is why these seaweeds will be chosen for the cultivation, and this will have applications like this. So why we are working on seaweeds? Because seaweeds are an area which is being used in various applications, like every day. Every day we are using seaweeds knowingly or unknowingly. For example, starting from the toothpaste, there the seaweeds like carrageenan is used as a gelling substance, and then we also use alginates. We also agar, the agar we use in the Cadbury's. So Cadbury chocolates, the gelling property has been brought using agar. So because this agar, alginate, and carrageenan, all these seaweed polysaccharides are excellent gelling agents for different products like food products, pharma products, or in slow release drug delivery applications. So what that is why World Bank in 2023 they have released one report where they're expecting the increase of the seaweed market in various categories up to 2030. For example, like biostimulants are mostly the seaweed derived plant nutrients in the liquid form or in the solid form or even in the gel form. So the market is expected to be more than 1870 million US dollars up to 2030. And similarly, seaweeds have been extensively used in animal feed, additives, and in pet food, and as an nutraceutical and as an alternative to proteins. So lot of areas where seaweeds are finding their applications. Uh, and this that is the reason why the research on seaweeds is very important. So what India is doing exactly in Indian scenario, I'm just briefly talking about the Indian scenario. Then after this, I will start the IPR which we have done on seaweed. The Indian seaweed, you see, India is not doing very well in the seaweed. It's not doing very well in terms of cultivation of the seaweeds. So this data you can see 35 million tons of seaweed was produced in 2021, and in this only 0.2% was Indian contribution. So that is why the cultivation of seaweeds in India is very low in comparison to the global scenario. But still, we are improving a lot in this area, and it is a growing field in country because India having 17,500 kilometer long coastal line, and we have inhabited our seawater is inhabited of more than 800 different type of seaweed species. So a lot of seaweeds are available, like which falls under rhodophyta, chlorophyta, phaeophyta, and more than 6 lakhs tons of fresh weight of seaweeds are available every year in our country. So it's a huge potential of the seaweeds market in India. That is why I just talk about why seaweeds are important for India, because these products like semi-refined carrageenan and refined carrageenan from cup of acres have been imported in huge quantities in our country, because we have food industries, we have cosmetic industries, we have plant biostimulant industries. So this has been imported in a huge quantity. You can see more India is importing more than 2,000 metric ton of this particular product every year. And similarly, agar has been imported more than 1,500 metric ton, like alginate has been imported more than 2,100 metric ton in our country. So these are the yearly consumption of this particular thing. And the production, you can see the production is very low, like 300, 400, 200 metric ton. So the more than 75 to 80% of this particular products we are importing for other countries. And other thing is that the seaweed plant biostimulant market is very big in the world, more than 6.2 billion US dollars. But in Indian market is not regulated, because only in 2021 it has come under Fertilizer Control Order 2021 Amendment Act. So now it is going to be registered. So we don't have any data on Indian consumption of plant biostimulant, but as a product called Sagarika, which is our technology based product sold by IFCO in the market, they have sold 60,000 tons of the granules, solid granules in the market in 2020-21. And also they have sold about 15 lakh liter of the liquid in the market. So it means the huge demand of this particular seaweed plant biostimulant is there in the market. So these are some of the photographs of the products available in the market based on our technology. And apart from this thing, this is the IPR position of our of the technologies which I'm involved. So there are 15 technologies, seaweed-based technologies, patents we have done, and among this, I'm involved in more than 22. We have done. I'm involved, but among 22, 15 are basically connected to seaweed and seaweed value addition. So I'm going to talk about some of them which are commercially we are successful. So this is the first technology I'm going to talk about. It is the Capoficus alvarezi-based plant biostimulant and carrageenan. So it is an integrated process basically to produce a plant biostimulant and carrageenan from a seaweed called Capoficus alvarezi. So Capoficus alvarezi is a red seaweed which is cultivatable seaweed. It has to be cultivated. It is not abundant naturally, but you have to cultivate this seaweed. And naturally, what is the novelty, or what is the what is novelty we have brought in this particular thing is that normally Capoficus alvarezi is normal. What people used to do, they conventionally they dry the seaweed and then they use the seaweed to extract refined and semi-refined carrageenan. So as I told you, these are very important products for the food and beverage industries. So, but what we have done that we have taken the fresh seaweed, and the fresh seaweeds when taken out from the sea. So you find that it has around 90% water content. So when you are mechanically giving some force, you are mechanically expelling the liquid from this. So you are going to get a liquid, which we call it liquid seaweed plant biostimulant, LSPB in short. And you are going to get another product in the solid form. It is called granules, okay, or residue. So this LSPB is a very good plant nutrient. It has been sold by IFCO, name of Sagarika, and Kripco, which is another big cooperative society company, which is selling this product in name of Sibarika. Okay, then these are the patents we have registered, we have filed in different countries. Why these different countries? Because in these countries the activity of seaweeds are more. Therefore, we have chosen to apply or file for these particular countries. Then what we have done, we have done a field trial of this liquid, because since once you are telling that it is a plant biostimulant, that the field trials experiments are very important. So our agronomist, agronomy department, they carried out the field trial in all over India, with the collaboration of ICAR and other agricultural universities. So 170 field trials has been done with different crops, like all cash crops like sugarcane, potato, rice, maize, green gram, black gram, sesame, soybean. So here, everywhere, all the crops, the yield of the crops was found to be increased up to 37%. And it has, as I told, that has we are importing a huge amount of plant biostimulant from other countries. So there is a potential of reduction of import by 2,000 crores, which has been we have calculated the estimated figure. And we have also published various publications to support our findings by publishing in high impact journals. And this is the product which launched just recently in February 2023 by Kripco, as the name of Sagarika, which I mentioned. And this has been also very successful in the market at this point of time. So what exactly this makes this liquid very potent plant biostimulant is that because it is rich in hormones. Like we have developed a process method for identification and quantification of plant growth hormones like indolacetic acid, G18, Ga3 in this. And if it is quite good amount of this plant growth hormones are present in the liquid. Apart from this, it is a very good source of potassium. You can say more than 2% potassium is present in this pristine sap. So the kappa sap, which is directly coming out from this sap. And the beauty of this Capoficus seaweed is that it accumulates potassium more than sodium. So normally what happens in the seawater, the seaweeds, they accumulate sodium more, less other minerals. But this particular seaweed is accumulate potassium more, less other minerals. Like potassium content is sodium content is much lower. You can see only 198 ppm sodium is present. On the other hand, potassium present is more than 2%. So it is huge difference between the potassium and sodium content difference. So that is why it is working like a magic for the various crops. And apart from this, it is also good source of micronutrients like zinc, manganese, iron, copper, and macronutrients like calcium, magnesium is already there. And it is also a good source of amino acids. Like this much amino acids we have found it out in this particular sap. And this make it, and apart from this, it also a good source of quaternary amino source like choline, glycine, betaine. So it make it suitable for the application in drought affected areas. And this is a summary of the technology which I told you that is increase the crop productivity, and 25% reduction in the recommended dose of fertilizer has been observed after application of this particular seaweed plant biostimulant. It's a huge number, and also it has been proven to be benefit to the soil bacterial community, and it has reached the 10% of the Indian biostimulant market through IFCO. So that is a great achievement for our institute, that this technology has reached to up to this huge number of farmers in the country. So, and we also been recognized in the form of some awards from CSR. So these are our licenses, like 12 licenses has taken this technology from us till now. And we have earned a revenue around 283 lakhs from this technology. And you can see that most of the licenses are MSME, and they are working very well in the market. And we also involved, we also been associated with famous brands of the country like IFCO and GRIFCO through our licenses. So this is what a very successful technology from our institute. And since, as I told you, that till now seaweed biostimulants are not regulated, only in 2021 the FCO Amendment Act has come into place, and it is going to be included in the 6th schedule of this FCO. And for this product need to be tested for toxicity, field trial, chemistry, and heavy metal contents, that we have already carried out the toxicity analysis in GLP accredited lab. And this product found to be non-toxic in all 9 parameters which has been identified by FCO. And these parameters include 4 parameters ecotoxicity and 5 parameters for ecotoxicity. So all foods like birds, fish, earthworm, rat, and other all the toxicity study found it is non-toxic to any of the matters. So, and chemistry also, and it doesn't have it has a little bit of heavy metal, but it is under the permissible limit. And the chemistry also is good, and it has a good shelf life. It's good. It is the shelf life is 3 years, which we have tested. This is one of the plant of this is the Aqua-Agri Processing Private Limited, which taken this technology for the first time from us. So this is a plant they have established in Manna Madurai, and this is producing a huge amount of liquid and solid for normally carrageenan is produced from the dry seaweeds, but in this particular technology, from where we are producing from the residue remained after the extraction of the liquid. So that SRC and refined carrageenan and semi-refined carrageenan, which we are producing from this particular residue, we have tested it, and we also compared the property with the specification available from food chemical codex for the application in the food grade applications. That we found that our product, business SRC, this semi-refined carrageenan and refined carrageenan, both produced from the residue, it falls under this specification, and it can be used for the food applications. So it is what we have done in this particular case. This is another technology. This is the technology on a brown seaweed. It is also a plant biostimulant technology again. But unlike Cauophycus technology, Cauophycus, the difference with this technology is that Cauophycus is a red seaweed and water is present inside the seaweed naturally. But in this case, hello, is it okay? Hello. So in this particular technology, this unlike Cauophycus, There's no water is present in sargassum sap. So what we have to do is that in sargassum, it is a brown seaweed, naturally abundant. So in this case, you have to extract the nutrients present in the seaweed using alkali. So after the extraction, what happens is that you are going to get a liquid seaweed plant based in the liquid form, and you are going to get a huge amount of residue, around 30%. So this residue, we are not throwing a single gram of the seaweed. We are converting this residue into various products like biochar, cellulose, or alginate. And also we're fermenting this particular residue to get fermented soil nutrient. And this way, this is almost 100% utilization of the seaweed biomass. And this biomass is adequate, means huge amount of biomass that I'm going to give you the figure also in the next slide. And is a cost effective production in the sense, if you are going to get 1 liter of liquid seaweed plant biostimulant costing around only 15 to 20 rupees per liter, including the preservation of the liquid. So it is a very cost effective production. Then the multiple products we are getting, we are not producing any waste. So we are not using any harmful chemicals in this particular process. And excellent bioefficacy we are getting. We have tested for the bioefficacy for cumin, onion, and groundnut, and about 13 to 28% increase in the crop yield was observed. And it is compatible to soil microbes, and it is alkaline in nature. Alkaline in nature is good for the soil because most of the soil in India are starting to be acidic. So this alkaline is always better for the application. And plant-based element can be easily converted to various formats like solid. It can be converted to gel form. It can be converted to viscous fluids. It can convert to peat form. So these are the various forms you can convert this particular plant-based stimulant. So these are our field effect on tobacco plant and on chickpea plants we have found, and 10 to 12% increase the leaf size of the tobacco plants we observed. So this is the licenses again. There are 10 licenses for this technology. I've taken license with license technology to 10 licenses till now, and we have earned around 91 lakhs of revenue from this technology till now. And this our licenses. This is one of the plant I'm showing in the bottom. This plant is placed in Anand, which having a capacity around to produce 10,000 liter of liquid per batch, and it is a fully automated plant and is working very fine at this point of time. And as I told you, that plant-based stimulants again comes under the FCO with under the Schedule 6 of the Amendment Act. So for this also the toxicity field trial data we have done, and toxicity all the 9 toxicity parameters we have carried out, and this found to be non-toxic in all the parameters, and the heavy metal content is also under the permissible limits. So this is another technology apart from cowpikers, which is very successful from commercialization point of view. So this is the summary of that particular sargassum-based plant-based stimulant technology. So what it do, it helps in the early germination of the seeds. So it also profuses the development of primary and secondary root and shoot. This is what we observed, and it increases the soil microbes, and it uses the fruit drop. Fruit drop, I can tell you, we have sent samples to Kashmir. In Kashmir, they have observed that the color of apple and the drop of apple from the plants has reduced substantially when this particular sargassum-based plant-based stimulant was used. And also we have seen from the groundnut, you can see this is the number of shoots and shoot length and root lengths were observed, and number of groundnut is increased. The onion number of crop yield of onion and cumin. So this is what I mean. And apart from this, we have also done one research on Gracilaria edulis. This is another seaweed from sap. It's another red seaweed again. And also liquid can be produced from this Gracilaria edulis. And these edulis have also been field trialed across various case crops like sugarcane, potato, and this is also working similar to cowpeka solubility. But only issue is that Gracilaria edulis, we have also done the cultivation, but this technology on Gracilaria edulis is not being transferred till now. So the importance of this technology on sargassum is that sufficient biomass is available in our country, As I told you that regarding the biomass is the major issue on any seaweed products. When you're working on seaweeds, then you have to ensure that the biomass is available in adequate amount, such that the technology is successful, commercial exploitation is useful. So, as far as sargassum is concerned, around 60,000 fresh tons of biomass is easily available in Tamil Nadu coast only. So, in 60,000 tons of fresh biomass per year is available. And among 60,000, only 15 to 20,000 tons of biomass is being used as a feed for the alginate processing industries, and remaining remain available for other commercial exploitation. This means for plant biostimulant production, there should not be uh, any shortage of biomass. And it is also a good substitute of the expensive imported seaweed products. Mostly in our country, more than 20 Indian companies, this is a very, very conservative figure, more than that, Indian companies were importing seaweed fertilizer, mostly Ascophyllum nodosum based. So Ascophyllum nodosum, what we have seen that nutrient content of Ascophyllum nodosum and sargassum is almost similar, because Ascophyllum nodosum cannot grow in India because it is a cold water seaweed, and it can be only found in the water of cold water around 5 degree temperature. So in India, you cannot get Ascophyllum nodosum. So the substitute of Ascophyllum nodosum is sargassum. So we are trying to establish sargassum as a alternative to Ascophyllum. So if it works in long run, then main lot of import of this particular seaweed can be reduced by using sargassum in place of Ascophyllum nodosum. So as I told you, that there is just a small figure. We are importing a huge in only in 1 month from InfoDrive India. I've just seen that India has imported more than 8,96,000 causing US dollars in only in 1 month in plant stimulant or seaweed fertilizer we have imported in 1 month. So it is a big number, and the proliferation of this sargassum technology to the people or to the farmers will help us to reduce the this import, also to reduce the import. So Atmanirbhar Bharat and Make in India is also going to play a very important role. The companies which have taken our technology are mostly MSMEs, and mostly they are producing under the campaign of Atmanirbhar Bharat and Make in India. So apart after this, there is one technology which I'm involved is the alginate.
You have gone mute. Dr. Prasad, you have gone mute. Dr. Prasad, please put on your mic. Your mic is off. We can't hear you.
It's trying to show something different.
माइक नहीं चल रहा ना पर इसका.
अभी ठीक.
Hello, can you hear me?
Yes, we can hear you.
So I think I was here till now. Is it okay now?
You put it on slideshow.
Yeah. So this is the technology on alginate. Normally, what is happening in alginate production is that lot of effluents are being produced in the form of acids and alkali, because you need to treat the seaweed with acid first, and then you have to treat the seaweed with the alkali. So that is the reason why lot of alkali and effluents are producing. So what we have done in this particular technology is that we have converted all the solid and liquid residue, the liquid effluents, into useful products. Like the solid residue we have converted to crude cellulose, and the liquid effluent we have used to plant biostimulant. So that's the way we are producing sodium, ammonium, potassium alginate with yield of more than 25 to 30%. And here we are not producing any solid or liquid waste. And this process, what we have developed, is suitable for all type of alginophytes. And apart from these three types of alginates, we have also able to produce PGA alginate. PGA is a polypropylene glycol alginate. So this alginate is extensively used, and there is no producer in India to produce PGA alginate. And this alginate can be produced, which is used in as an emulsion in the food industries. And then the high viscosity of biopolymer was observed in this particular, and we able to also able to reduce the water footprint by 25%. So these are the novelty we have brought in the particular this technology. And apart from this technology, we are also working on, and as I mentioned, this the previous technology also been transferred to a MSME, which is known as United Lignite. It is based in Bhavnagar only. And then we are doing some work. Still, this work is continuing. Because last year also we worked in collaboration with Unilever, this particular project, and now we are working in collaboration with a company called Agrocell and another company called Circla Technologies from Mumbai. And actually, basically, in this particular work, we are trying to develop sustainable packaging materials from seaweeds. And these biodegradable packaging films, which we are producing from seaweeds, are hydrophilic in nature. That is the biggest challenge we are now facing with these particular films, because since they are prepared from seaweed polysaccharides like agar, carrageenan, and alginate, so they are in hydrophilic in nature. But when we're trying to make it hydrophobic, then we are losing the biodegradability of the particular films. So that is a challenge which we are trying to work. And this particular seaweed-based packaging films are good having the heat solubility, although the heat solubility is not that strong like polythenes or like that, but we can make small pouches, and the oily and solid materials like fruits, oil, detergents, grease, and salt and bread type of things can be stored into this particular biodegradable films. And this also biodegradable films will be able to make it antimicrobial nature, such that perishable items also can be stored for a long time. And also we have used this particular packaging films for the storage of fertilizers. And these films have very good tensile strength, like around 25 megapascal you can get, and elongation is good, around more than 100% elongation, and the water vapor permeability is low, which makes the fruits and other things fresh for a long time. And these are very good foldable materials, and they are odorless and then antioxidant nature, because the materials is present inside, you can fortify it any water soluble antioxidant compound, like you can fortify it with lactic acid, you can fortify it with ascorbic acid, anything you can fortify it with. And it has antimicrobial property, and in soil condition it takes around 6 months to completely biodegrade, but in laboratory conditions it takes only 15 days to completely disappear. And for this biodegradation studies, what we have done, we are using all a concentrate of bacteria which we are isolating from the soil of the garden soil, and we are putting directly into the films, and we found it in 15 days this films completely disappeared. And if we talk about the cost of this particular films, the cost is a little bit higher, which is again a bottleneck of this particular technology. The A4 size film, when we are preparing, the cost is around 1.5 rupees. But this cost can be, we can see, because this type of film forming materials can be also converted to, you can see, like capsule cells. So this capsule cells cost is around only 2 paisa. So what we are trying to do.
ये आपका फिर से म्यूट हो गया है डॉक्टर प्रसाद. You have to unmute your mic.
I don't know.
And now it is all right.
It's okay?
Yeah, it's okay. The slideshow mode में भी कर दीजिए आप अपना slides.
Yeah, that's okay.
Yeah.
Okay. So as for some strange agent is going muted suddenly. So this is what is the films are, and the capsule cells which we have prepared from seaweed biopolymers. Again, this is another technology. This is a directly isolation of agarose from seaweed. So normally what happens is that what invention we have done in this particular technology, and as you know that there is a difference between agar and agarose. So agar is having certain charges in it, which make it unsuitable for the use in the electrophoresis. So when you are going to use a gel in electrophoresis, the gel has to be totally neutral. So that is how when you are going to prepare agarose from agar, you have to remove the charges from agar. So how usually people do? They use precipitation method or the ion exchange method. The two methods are normally used to remove the charges from agar and to produce agarose. And it is the reason why the production of agarose is so high and the cost of agarose is very high. But what we have done in this particular technology is that we are not using any type of purification, and we are using directly the seaweed, and we are precipitating using a surfactant into the room temperature. And this product we are isolating at room temperature where we are getting agarose directly from the seaweed without going through any purification. That is the reason why the production cost has reduced to around 2,500 rupees per kilogram. And the similar grade of agarose is sold in the market around 50,000 to 3 lakhs rupees per kg. So you can see the gel strength value in the table here. In gram per centimeter square, if you talk about, it is more than 1% gel, more than 2000, but in our case, and a sigma and sigma agarose low EO is electrointensive value. This determines the charges present in it. So lower is the EO, higher is the price. So ours comes under this particular, this A0547 category. And the gel point and everything matches with that product is sold by market into by segment very high cost, and ours matches all that. And our product has been benchmarked by third party like Mark, and then our sister laboratory IGIB, and they found it this as good as like commercial products. And we have done the trademark registration for this particular product, and we call it Sagarose. And this is another proof of concept technology for production of multiple products from seaweeds. What happened is that to increase the economic feasibility, you have to use the seaweed for the production of multiple products. So in here we tried to demonstrate the concept of biorefinery model, where we use the agrophyte to produce liquid fertilizer, then pigment, and liquid, then agar, and a bioethanol. Bioethanol is from the cellulose, which we are producing from the resting. So that's the concept technology, and can be used for the production of multiple products like from seaweed, and which will increase the economic feasibility of the technologies. Well, this is another technology which on R-phycoerythrin. So R-phycoerythrin is a red pigment which is present in normally in the red seaweeds, and this is a very high value pigment which is sold by Sigma Rich 1 milligram costing 11,300 rupees. So what we have done, we try to develop a method, and we have developed it using goods buffer and liquids. And in this particular method, we use these benign solvent systems. They are environment friendly solvent systems, and we able to produce our phycoerythrin costing around 10,000 per gram. And what we have done, we have used this particular process for the extraction of the pigment from different seaweeds shown here, the some photographs. And these are the seaweeds which we have used for the like Gracilaria corticata, Capafica silveracea, Agardilla, Subulata, Helvenia, Gelidium, like the total 11 to 12 seaweeds we have taken. And from all the seaweeds, we found that there is a seaweed called Gracilaria corticata, who is found to be very good source of R-phycoerythrin. And this we are scaled up to 50 gram level, and that work is also presently going on. And this is another research work which was patented from seaweeds. It is the graphene production from seaweed biomass. So as I told you that from sargassum, this is our technology we have developed where we are producing liquid seaweed plant based stimulant. So from this, when you are getting the waste product from the sargassum, that is where we are converting it to agro-nutrient values like fermented fertilizers, then we are using to cellulose and other. So there is another option of converting it to graphene. So that is also a research we have done, and we are able to convert this graphene, the seaweed waste product to graphene, and this graphene was used to remove the fluoride content from drinking water. And this water we have brought from Govindgarh, means in Rajasthan, there is a village highly affected fluorinated. A lot of people are suffering from fluorosis, dental fluorosis disease. So from that particular village, we have brought this particular water and found that 95% fluoride can be removed using this graphene. So this work also I consider to be very, very important. And this is another work here. Seaweed is used for fortification. As I told you that the biostimulant which we are producing, having lot of micro and macronutrients, but the nitrogen content of this particular plant biostimulant is quite low. So the reason why we are searching for some good bio-based or marine-based products which can fortify these plant biostimulants. So this is where we started working on chitin from waste fishery, like waste prawn shell we used and we taken from the market only. The waste prawn shells were converted to chitin, and chitin was that. So another problem with chitin is that since LS liquid sweet plant biostimulant is water, it is a water containing product. So something has to be mixed with it, has to be water soluble. So since chitin is not water soluble, then we try to modify chitin. So we have modified chitin in such a way that we make the chitin water soluble, and also we have fortified chitin during the neutralization process with some alkali, which is plant micro and macronutrient content. And this particular liquid, when we use to fortify the seaweed plant biostimulant formulations, and also we have used this particular plant biostimulant formulation for the absorption of bentonite and dolomite granules, which are also used in the plant for plant nutrients. So this particular patent also we have patent file, and this also is not commercialized till now, but discussion is going on with some prospective companies. And the waste remain after removal of waste for the this waste liquid was used for the cultivation of chlorella. So that is our microalgae team has done this, and is found that this fishery waste liquid can be used for the cultivation or culture of microalgae. So this is another work, again, is a fortification of plant biostimulant with proteinous material like amino acid. It is a low amino acid content in plant biostimulant. So here what we have done, we developed a method for the extraction of keratin from human hair and chicken feather and animal wool. And this particular keratin, after hydrolysis, we used to fortify the plant biostimulants, and these waste proteinous products are found with very good content of keratin. And this is and also we have done some pot culture experiment to see the efficacy of this particular formulations, and we found that these formulations are really work good, and these formulations are all soil bacteria compatibility was also observed for this particular thing. So thank you very much to all of you for listening to me for last 40 minutes. So I'll be now happy to answer your queries. Thank you.
Thank you, Dr. Prasad. We will take a question answer session. I'll pass on the mic to my colleague, Dr. Deepika. She will take the question answer sessions. Before we start that, I will have Mike very satisfied first. So there is a recent article that I read that Capophycus alvarezii that you said of red seaweed that you said, the first one that we had discussed, which is used for plant biostimulant, fertilizer, and bioethanol production, and a lot of things which have been applications, and it has been widely worked seaweed especially in CSMC area, Bhavnagar. But there are a lot of reports that this is an invasive species. And though you are doing under cultivation, this species is an invasive species, and it has an impact on the coral in the sea, and it kind of does not allow it to grow. So what are your impact on them? Because, corals are also very important, if you say ecologically and environmentally. So what do you have to say on this cultivation of invasive species? First of all, is it an invasive species which is, impacting the coral population in the coastal areas? And second, if at all it is, what are the steps that have to be taken so that, because it is very beneficial, as we see that we are able to get a lot of commercially viable products from the species. So what are the steps which are important if we are going in for cultivation of this?
I think you have asked a very, very important questions, and this is a real debate is going on Capophycus. People are telling that it's invasive species, but our team in Mandapam, they have checked personally also. So the invasion which people are telling it's not that serious what people are actually trying to show. That is not the way it is invading, because it is actually this Kappa ficus is not an Indian species. The Kappa ficus was brought by one of our scientists from Indonesia. Only 5 grams of the seaweed was brought by agreement, and then only it is proliferated in this much number. And this is the only seaweed which is commercially so much important and successful. So what we are trying to do is that if at all it is invasion is observed, which we are not very sure about, because we are also trying, and we also studies going on from our side also to see the extent of invasion it is doing on.
Just a minute. Have you studied the impact on coral population while you are doing the the product development from that?
Yeah.
Have you made studies on whether it has?
I think you are muted. Hello.
Yeah. So, have you made any studies on impact on coral population?
Yes. Now, coral stone we have not made that much study, but the technology impact we have done on the people who are doing the cultivation. But the coral thing has not been done of that large scale. But the study already initiated at our Mars Mandapam level. And I think next 1 year we'll able to get some data from them. But initial study already they have done. But large scale study they are doing. That is what is happening. And also our now aim is to do it in a land-based cultivation, in ponds or in the shrimp ponds or shrimp pond type of, which is not connected directly to the corals. That type of structures also.
Ponds is all right.
Yeah.
That is what that is why the second question was, what are the steps you are taking that it does not impact the coral population if it has? So that is of course, important part that you are doing it in ponds and all. If the cultivation is in that format, then of course, even if it has impact on coral population, it will not have a large scale devastating impact on coral. If we are doing it in catchment areas like lakes and ponds and all those things. So that is all. Lipika will take all the question answers now from the audience.
Thank you very much, Dr. Prashant, for this very enlightening talk on IPR protection, commercialization aspects of seaweed-related technologies. And you have provided very insightful and very interesting insights into why this research on seaweed is important for in India, and what are the potentials of seaweed-based, what is the potential market for seaweeds in India or seaweed-based products in India. You have focused on Kappa ficus as and sargassum as potential plant stimulants, how they have been proved to be capable of handling the different parameters, toxicity and its use parameters. You have also focused on alginate-based technologies and sustainable packaging material from seaweeds, agarose from seaweeds. You have elaborated different facets and how pigments could be produced from different seaweeds. You have also focused on removal of fluoride by graphene and use of chitin and keratin as plant biostimulants. And all this you have protected by potential patents in India and other jurisdictions, and they have also been commercialized. So you have seen every facet of technology development, its protection, its licensing, commercialization, and benefit to the society and the industry as well. So now this session is open for question answer. I'd request the participants to raise their hands, and when called upon, please introduce yourself and proceed with your question. And you can also provide your question in the chat box, which I will be putting through to the speaker. Dr. Raghunath, please send.
Yes.
Good morning.
Sir, very nice session, sir. Thank you for that your session. Sir, I have one question. Sir, for a collection of the seaweed, whether we have to get NOC from local DFRO, or anyone can collect the seaweed to start the research, or we can produce the product?
Yeah. No, you can start. There is no permission is required. Only if you are going to collect in large quantities, then the respective maritime board has to be informed.
Sir, can we grow that seaweed in our own area?
Of course you can grow. There's no issue. There is no such regulations there in our country to stop growing of seaweeds in any other places.
Yes, thank you, sir.
There is another question from ESPCSR.
Hello, sir. Yeah. Hello. Hi. Kamlesh sir, it's a very, very excellent, presentation. You talked about the technologies, it's like we can see the publication, many publication, not in terms of technologies. So we are very excited to see your technologies. And since I'm in the fermentation field, like in terms of cultivation and especially these food products like carrageen and this one. So 1 kilogram of the material which you are getting from the seaweed, and for that the raw material cost and seashore, the cultivation, the permission, the raw material and cultivation, the time of the cultivation before extraction. So is it very economic when you make rupees 500 per liter, or for like
Yes.
the seaweed in the liquid form?
Yeah, very good.
I will
question,
request just a minute. I will request all the interactive scientists to first introduce themselves, because we do not know who is asking a question. So right now, please introduce yourself so that we know who is asking the question.
Yeah, I already mentioned. I am Dr. Senthil from CSR Imtech. I'm in fermentation division. So my question to you, sir,
sorry, we missed your name. So yeah. Please go ahead.
Yeah, Dr. Senthil, thank you very much. And since you are from fermentation technology, we have option to collaborate also. So I'll write to you separately. But to ask to reply your question, that's Capaficus alvarezi, I'm just taking example. It is sold in the market by the growers at a cost of rupees 15 to 20 rupees per kilo of fresh seaweed. Okay. So fresh seaweed. Suppose 1 kilo fresh seaweed you are taking. Suppose costing around 20 rupees. Okay. So from 20 rupees, you are mechanically crushing it. Okay. Then you are going to get around 650 ml of liquid. Okay.
Liquid.
650 ml of liquid you are getting. And this 650 ml liquid has to be concentrated by 4 times to sell in the market. So you are going to get around 160 ml of liquid. Then you are also getting another product which is called residue. So you are getting around 350 gram of solid residue. Okay. So this solid residue is having a moisture content around 65%. So you are going to get around 180 to 90 gram of residue. So from 180 gram residue, 65% yield is semi-refined carrageenan. So you are going to get around 100 gram of semi-refined carrageenan from the residue. Okay. Now 160 ml liquid, you are selling it in the market. Suppose 500 is the selling market, but you have to sell it around cost 350 to the dealers. So if you are selling at 350 rupees per liter, so for 160 ml, you are going to get 56 rupees. Okay. 56. And at SRC cost is 700 rupees in the market. Market it is sold at the cost of 1000, but you have to sell it at the cost of 700. So 700 when you are selling, so you are going to get 70 rupees. So from 1 kilo of seaweed, you are going to get 126 rupees.
Okay. So production cost, including the production cost.
Yes, including the production cost. So 100 rupees by keeping everything in conservative figure also, from 1 kilo of seaweed, you can definitely get 100 rupees.
100 rupees. Okay. Yes. Excellent, sir. Thank you.
And about the sargassum thing, it is more beneficial than this. Sargassum, 1 liter production of sargassum plant by unit, it costs only 15 to 20 rupees. And it is easily sold in the market at a cost of 250 rupees.
Okay. Sir, in terms of coastal, if there is any inland pond kind of system, can you simulate the same type of artificial seawater? Because the person who access to the seashore only they can do this technology. There are many inland system out there. So have you compared that technology production from the sea coastal area to this one, to the inland pond kind of system?
Dr. Senthil, actually, this is a very growing area, and a lot of people are also working on it. And the pond system, only the growth rate is a little bit lesser than what we are observing in the sea. So that is a little bit detrimental from a commercial point of view. But pond, it can be used for the growth, and this is the future actually. You cannot access the sea, that investment and everything is coming into the place, and many people will come because India. More questions are asked before the technology is grown. So that is what Indian things are. So we have to take care of all the things. So we have to think about the plan A, plan B, all the things.
Okay. Thank you.
Yeah.
Thank you.
There is a question from Dr. Manoj from CCMB. Any plans for check for possibility of biopharmaceutical derived from this technology from relevant seaweeds or associated algae?
Yeah, I think Dr. Manoj, you're the right person to work on it. Because biopharmaceuticals from seaweed in India, our institute at least have not worked, but Central Fishery Marine Institute with Mandapam based one ICR institute, they are doing on it. But we are not working directly on the biopharmaceuticals from seaweed at this point of time. But our focus is mostly on the commercial plant biostimulants and biopolymers. Please write to me, Dr. Manoj. I'll be happy to collaborate with you, and I will connect with you, our colleagues who are working on this area. And please write to me or let me know your email ID. I'll write to you.
If somebody, Dr. Senthil, if you have already asked question, can you put your hand down? Or if you want to ask one more question.
No, nothing.
Please put your hand down then.
Are there any further questions?
If there are no questions, I will ask one more question. You had mentioned the packaging material developed from seaweeds, and you had mentioned that they are hydrophilic in nature. And you mentioned that they are used for packaging of the fertilizers that you are, mostly the fertilizers part that I understood correctly. One question is, what is the seaweed which you are using, or it is a mixture of them? And second is, mixture of them. And second is, what is the shelf life like?
It is another good question again. Actually, the seaweed which we are using is Capaficus alvarezi again, and we are extracting the carrageenan from the Capaficus, and we are using for the packaging, for preparation of the packaging films. And second, polysaccharide we are using the alginates, sodium alginates from sargassum. So this, because these seaweeds are abundant, so we are using these seaweeds as a source of materials. And these are actually for 3 years. The shelf life is 3 years. For 3 years, you can use the films without any problem.
So when it is hydrophilic, the moisture content in the air does so. I understand that hydrophilic water will also.
It is not hydroscopic actually. It has some hydrophilic because when you're putting in water, so it takes 12 hours to complete dissolve. So it does not catch water from outside. It is not hygroscopic.
So that is why I wanted to ask whether the moisture from the air will impact it, because you said 3 years shelf life. 3 years shelf life means it is okay.
So I would like to ask one question. Myself is Yogesh Doble. I am a scientist in Innovation Protection Unit of CSIR. I would like to ask whether what are the indirect benefits you are getting from filing of patents in your research area? Are you getting any kind of foreign research collaborations or any other benefits you are getting from having those patents in your portfolio?
I think Yogesh has asked a very good question. It is related to your IP. Actually, the CSR has taken a policy that we are now patenting only in India. It is what is happening for us for last, I think, 3 to 4 years. So before it, when we patented in other countries, that time the visibility was more. It is the fact which I'm telling you. But when you are patenting an Indian patent, also taking a lot of time to get the grant and everything. So from Indian patent application point of view, we are not getting that visibility. Instead of when we started, when we used to patent in US or PCT, but I know that is a very expensive thing also. And only the patents which are having the commercial value should be patented. That also I agree. But the Indian patents are not giving us that visibility which are expected. Because it is a very closed domain. Nobody is getting access to these things. But we publish papers after the patent number we get. So that give us more visibility.
I would like to add something here. When you are transferring your technology if it is supported by a strong patent, even if it is filed, or of course, if it is granted, then very good. If it is supported by a technology, it will give you way ahead of in the licensing aspect while negotiating with the licensee and with for the commercialization, and it will be finally helpful in commercialization of your technology. And
Yes.
regarding grant of patent in India, if you are talking about the time lapse that is happening, what you can do is you can request us IPU here that your application, the request for your application is submitted as early as possible, because we generally take around 3 years of time. Now we are trying to reduce it, but in case you want it to be examined and granted as early as possible, you tell us so that we can expedite that thing from our end.
Yeah, so there is a possibility of expedited examination, which we can do from our end. However, the fee is higher. It is three times the fee that but it should be like, if you are licensing the technology and if it is beneficial for your negotiation part, that patent, we can always do that. And we are supporting CSIR IPU is supporting all such requests. If it is, especially if it is related to technology licensing, we are very, very keen on that. So we support it.
We must appreciate your IPU team, because one patent I got filed in 7 days from your IPU. So that is a really good experience what I have. And I'm really, and this, as Dr. Lipika told, that anything in the patent file also are helping us to negotiate in a more proficient way, the negotiations we are doing. So this is really a very good thing to protect. Even Indian patents, so we don't have any problem. But only what Dr. Jogesh asked about the visibility, the Indian patents have not that visibility.
Tell me one thing. I'm more interested in, while you are commercializing, like you said, you have licensed quite a few patents, technologies. Which other countries have you been able to license? Do you have any foreign partners? Because you have been filing in foreign jurisdictions also. As we see, your portfolio is 22. And I think this could be inclusive of, these are not unique patents, as we say. These are patents, maybe the number is 5, 6, and they are filed in more jurisdiction. So have you been able to, license in foreign jurisdiction?
Yeah, that is exactly what is happening today. Actually, we have already one company called Endorama. Endorama is coming to us for the Kawafakers technology. That is an Indonesia-based company, and luckily we have a patent of Kawafakers in Indonesia. So that is what the way they are coming to us now, and it is at the advanced stage of discussion. And because we have patented it in Indonesia, that is the reason that company is coming to us. So that is a thing we have found it, and this will happen in next, I think, 5 to 6 months. It will take to completely test our technology. This is an Indonesian very big company, Indonama.
We are happy to note that you are getting some collaboration and some licensing part from foreign jurisdictions also.
There are other hands raised. Dr. Sikha, please.
ये रघुनाथन का हटा देना अगर इसका हो चुका है.
Good morning, Dr. Kamlesh.
Yeah, good morning. Good morning.
Thanks a lot for the nice presentation. I just want to know, if you are talking about technology transfer and everything related to your Seaweed and their peripheral technologies and products, have you ever got a glimpse into what, if other people are using your products, then what's your stake on that? Do you inform your colleagues or IPU for that? See, because as per the experience in the field, the inventors are the best persons to know about the products which are there in the market. So have you come across any of such competing products which you have developed? And it's really, I would be really very keen to know if some people who are using your products, then we can have an study of the products in detail and then find out whether they are using our technology or not.
Okay, good. I think especially two products are very successful, like Sagarika. You can get it from IFCO, because since IFCO is involved, so it is reaching to the most of the people, and many people are doing business with the total 13 products are there from our technology which are in the market. And one of our scientists from BDM is now doing the social economic impact of this technology. So he's started the work and he has visited the various this thing also, the fields also, and he's trying to develop and reaching to the farmers directly, which are using our products, how they got and everything. So that study also we are taking care. And if IPU section can help us, we can share our data with you also. So the people, the companies which are producing and in marketing volume of products that also we are having.
So that will be nice if you can share it. We can do some kind. See, it's a new area for us also, but we will be interested to do it.
Sure, we'll do it because we have also started because also we thought that it is very important to know the impact of the products to the people. So that work we have started. Yeah.
Thank you so much.
Thank you, Rasika.
There is another hand raised, Dr. Razak from Ampri. Dr. Razak, please proceed with your question.
I think he asking him to unmute.
Actually, we have not mute anyone. You can type your question in the chat box as well.
If there is no question, then we will like to close this program. Write down the question. Write it down. Chat box में लिख नहीं रहा question. उसको लिखो रजा. Please write the question.
The question is there.
Okay.
Applicants and investigators who will get more credit after publication the patent file where we need to showcase our published patent or commercialization. So this is a question for IPU, I think.
Applicants and investigators who will get. Yeah, so let me answer that on behalf of Dr. Kamlesh Prasad. See, the question is applicant and investigators, who will get more credit? Applicant is CSIR. For any patent that is filed, applicant will be CSIR. Investigators are the inventors. So of course, if the technology is commercialized, according to CSIR technology transfer guidelines, the most important part about the monetary part will only go to applicant. There is no provision now that it can be shared with the inventors. Of course, the credit of patent as an inventor will always go to the inventors. So you will have that in your portfolio that you have patented it. and you can put it in your APRs and all your resumes and all, and this will give you this credit for that. But as far as monetary benefits, uh, the benefit will go to the CSIR. The licensing fee and the royalties earned will go to the LRF in the lab, to the lab, and a small part is shared to the headquarters. So the lab will get the maximum benefit, which will be shared with the headquarters. I hope it answers the questions. Hello. बोलो सर, बिल्कुल ठीक हूँ, बताओ बताओ. For what?
In case there are no further questions, I would like to thank the participants for their very active participation, and also the speaker for very interesting talk and very appropriately answering the questions of the and queries raised. Thank you so much. And now I request Dr. Bhanu to offer the vote of thanks.
It is my proud privilege to present a vote of thanks for this lecture today. This is the 5th lecture in the monthly lecture series. And I would say the participation had been very good today. So first of all, I would like to thank DGCSIR, under whose able guidance and support we have started this monthly lecture series as a WIPO Day celebration that we had, started this year in 2023. I would like to thank SCDD head, Dr. Mahesh, and his team for hosting the lecture on social media platforms. I would also like to thank head IT and her team for notifying on CSIR websites and putting wide publicity to this. Of course, Dr. Kamlesh Prasad, I would like to thank you for taking out your precious time to give a very illustrative and informative lecture today. Thanks, my heartfelt thanks are due to all the CSIR colleagues and participants who have attended this lecture on the online platform, MS Team platform, and have interacted with the scientist, Dr. Kamlesh Prasad, and our team at IPU. Thanks are also due to my CSIR IPU colleagues who have been supporting the initiative of monthly lecture series along with the team that is organizing this. I would fail in my duty if I do not thank the Director CSM CRI, Dr. Kannan Srinivasan, for giving the nominations for the lecture series. We have got 2 nominations. Of course, we have hosted one, Dr. Kamlesh Prasad's lecture today. Last but not the least, I would like to thank my head, Dr. Vibha Malhotra Soni, for her kind support and constant encouragement for new initiatives that we start at CSIR IPU, especially this monthly lecture series. Thank you all.
So thank you, all of you.
Yeah, welcome. Thank you.